Now the question is, let's go to discuss this question. Derive expression for equivalent capacitance of capacitor are connected in series. So this is the important question for IPE. Capacitors are connected in series. So I take here 3 capacitors. We know that these are the capacitor symbols. Each capacitance are C1, C2, C3 respectively. These are connected in series mean one of the plate of C1 directly connected to one of the plate of C2. Other plate of C2 is connected to the one of the plate of the C3. Now remaining part of the C1 is connected to battery. See here, other plate of C1 is connected to positive terminal of the battery. Other plate of C3 is connected to negative terminal of the battery. C1, C2, C3 are connected in series. So this is the combination of series of 3 capacitors C1, C2, C3 respectively. Now current is moving from positive terminal of the battery. Current is nothing but we know that charge, moving of charge from one place to other place. So here positive charge is moving toward the capacitor C1. Now positive charge is stored this plate of the C1. So this positive charge attract the electrons towards this side. Automatically other side positive charge is developed here. So this positive charge is attracted by the negative terminal of the battery again. So here positive charge is moving toward the C2 plate. Now positive charge is stored on the this plate of the capacitor C2. It attracts the electrons of other plate towards this side. So other side it get positive charge. So this positive charge again moving due to attracted by the negative terminal. So again this is the moving toward the C3. Again here C3 on this the plate it get positive charge. So this positive charge again it attract the electrons of other plate towards this side. So other side it get positive charge. So this is attracted by the negative terminal. So here positive charge is moving toward the negative terminal. So here charge current get closed circuit. See here only one circuit, only one way. So C1, C2, C3 are connected in series. Same charge are stored in each capacitor. Suppose battery potential is V. Here energy is given by the battery. Charges are stored in C1, C2, C3. So here electrical energy are stored in C1, C2, C3. So C1, C2, C3 take electrical energy. So battery given energy to C1, C2, C3. మనం సులువుగా అర్థం చేసుకోవడానికి నేను ఒక ఎగ్జాంపుల్ తీసుకుంటున్నా. ఇక్కడ బ్యాటరీ ఎనర్జీ ఇచ్చేవాడు, C1, C2, C3 ఎనర్జీ తీసుకునేవాడు. Suppose బ్యాటరీ 10 బ్రెడ్ పీసెస్ చేసింది అనుకుందాం. ఇక్కడ ఉండేది ఒకే ఒక హౌస్. ఆ హౌస్లో ఎంతమంది ఉన్నారంటే 4 మెంబర్స్. అందులో బ్యాటరీ బ్రెడ్ తయారు చేసేవాడు, వీడు ఇచ్చేవాడు. తినేవాళ్ళు C1, C2, C3. సో ఈ 10 బ్రెడ్లను వాళ్ళ కెపాసిటెన్స్ బట్టి ఒకరు ఎక్కువ తినొచ్చు, ఒకరు తక్కువ తినచ్చు. సపోజ్ C1 ఎక్కువ కెపాసిటెన్స్ అనుకో, వీడు ఎక్కువ బ్రెడ్ పీసెస్ తీసుకుంటాడు. తక్కువ C3 అనేది తక్కువ కెపాసిటెన్స్ అనుకుంటే వీడు తక్కువ బ్రెడ్ అనేది రిసీవ్ తీసుకుంటాడు. సో మొత్తాన్ని మాత్రం 10 బ్రెడ్ ముక్కల్ని C1, C2, C3 పంచుకోవాలి. ఎక్కువ స్ట్రెంత్ ఉన్నవాడు ఎక్కువ తీసుకుంటాడు, తక్కువ స్ట్రెంత్ ఉన్నవాడు తక్కువ తీసుకుంటాడు. సో వీళ్ళు ముగ్గురు కలిపి టోటల్గా 10 తీసుకోవాల్సిందే. See here, potential is given by the battery. C1, C2 are taken. So here potential are developed C1, C2, C3 depend upon their capacitance. Suppose V1, V2, V3 are potential developed across C1, C2, C3 respectively. Let V1, V2, V3 are 3 potentials are developed across C1, C2, C3 respectively. Potential of batteries should be equivalent to V1 plus V2 plus V3. We know one of the formula, Q is equal to CV. But here we have a potential, so here V is equal to Q by C. Come to the first capacitor. First capacitor capacitance is C1, second one is C2, third one is C3. So here in the first plate there is Q V1 C1, Q C1 V1. So what here V1 is equal to Q by, what is here V1 is equal to Q by C1. So I take here instead of V1, I take here Q by C1. In second plate, charge is Q, capacitance is C2, potential is V2. So what is the formula here? V2 is equal to so Q is equal to CV. From this formula, V is equal to Q by C. So here potential is V2, charge is Q, capacitance is C2. So here V2 is equal to Q by C2. Similarly, V3 is equal to Q by C3. So Q is common in all the terms, then we get 1 by C1, 1 by C2, 1 by C3. Now Q bring towards the side, then it become V by Q. That is equal to 1 by C1 plus 1 by C2 plus 1 by C3. You know, Q by V is equal to C, V by Q then V by Q become 1 by C. So V by Q is nothing but here 1 by C, where C is equivalent capacitance. So 1 by C equivalent capacitance is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is the answer. 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So C1, C2, C3 are connected in series, then we get the equivalent capacitance as 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. How did you write this answer? See, C1, C2, C3 are three capacitors are connected in series as shown in circuit as shown in circuit as shown circuit. Let Q is a charge. Okay, don't write a given energy by the battery and energy receiving by the C1, C2, C3. Okay, let Q is the charge stored in capacitors. Next, V1, V2, let V1, V2, V3 are three potentials are developed across C1, C2, C3 respectively. We know V is equal to V1 plus V2 plus V3. Then V is equal to Q by C1, Q by C2, Q by C3. So Q is the common 1 by C1, 1 by C2, 1 by C3. So V by Q is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So what is the meaning of this one? So here three capacitors are connected in series to the battery. So this is C1, C2, C3. So this is equivalent to one of the capacitor, C equivalent. To the battery. So these three are replaced by this C equivalent. So what is the relation C1, C2, C equivalent? That is 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is the answer. Now the question is, derive an expression for equivalent capacity of capacitors are connected in parallel. See here, I take three capacitors C1, C2, C3. So these are connected. Parallel mean three plates of three capacitors are connected to positive terminal of the battery. Remaining plates of three capacitors are connected to negative terminal of the battery. See here, C1, C2, C3 are three capacitors are connected parallel to the battery like in this way. Now let the potential of the battery is V. From the positive terminal, positive charge is moving. So at this the point, charge is divided into three parts. Some part of the charge moving along C1 way, some part of charge moving along C2, remaining part of the charge is moving along the C3. So here this positive charge is stored on these plates, one side of these plates. So this positive charge attract the electrons of other metal towards this side. So oppositely it get the positive. So in similar manner in these two plates also same process is done. So this positive charge again moving toward the negative terminal. So positive charge is moving. See here, at this point, these three charges combined each other and moving toward the negative terminal. Finally, here flow of charge is closer to the negative terminal. So it is the closed circuit. So charge is moving from positive terminal to negative terminal. Charge is moving only if there is a closed circuit. Remember that one. Anyhow, see here the charges are stored on C1, C2, C3 respectively. See here, charge is divided. Suppose Q is the charge is moving from positive terminal. At this the point Q is divided into three parts. So one is Q1, other one is Q2, other one is Q3. ఓకేనా. సపోజ్ మనకి ఇలా ఒక ఎగ్జాంపుల్ తీసుకుంటే ఒక రివర్ అనేది తీసుకుందాం. రివర్లో వాటర్ అనేది ఫ్లో అవుతూ ఉంది. దీనికి ఒక 3 ways వచ్చాయి. So some part of the water moving along this one, some part moving along this direction, some part is moving along this side, some part is okay. Like this way, charge is also divided into 3 parts: Q1, Q2, Q3. So here Q1 charge is stored in C1, Q2 is a charge stored in C2, Q3 is a charge stored in C3. So here Q1, Q2, Q3 are charges leaving from C1, C2, C3 respectively. At this the point again Q1, Q2, Q3 are combined and they get Q. So finally we get the charge Q and it is ended at the negative terminal. See here, on C1 charge stored is Q1, on C2 charge stored is Q2, on C3 charge is Q3. To understand how potential is divided along the capacitor connected in parallel, there are 3 circuits. So one of the circuit is along C3, second circuit is along C2, third circuit is along C1. So how many houses are there? 3 houses there. Now battery maintaining 3 families. ఈజీగా అండర్స్టాండ్ చేసుకోవడానికి ఒక ఎగ్జాంపుల్ చెప్తా. ఇక్కడ బ్యాటరీ ఎన్ని ఫ్యామిలీస్ని మెయింటైన్ చేస్తానంటే 3 families. సపోజ్ ఒక ఫ్యామిలీకి 10 చికెన్ బిర్యానీలు ఇస్తే సెకండ్ ఫ్యామిలీకి కూడా 10 చికెన్ బిర్యానీ ఇవ్వాల్సిందే, థర్డ్ ఫ్యామిలీకి కూడా 10 ఇవ్వాల్సిందే, 10 చికెన్ బిర్యానీ ఇవ్వాల్సిందే. అంటే ఒక ఫ్యామిలీని ఎలా చూసుకోవాలో, ఎంత ఎనర్జీ ఇవ్వాలో మిగతా ఫ్యామిలీకి కూడా అంతే ఎనర్జీ ఇవ్వాలి, లేకపోతే ఇంకో ఫ్యామిలీ ఒప్పుకోదు. సో బ్యాటరీ పొటెన్షియల్ 10 అనుకుంటే ప్రతి సర్క్యూట్కి 10 పొటెన్షియల్ ఇవ్వాల్సిందే. సో ఇక టోటల్గా వర్క్ డన్ ఎంత జరుగుతుందంటే 30. ఎన్ని ఫ్యామిలీస్ పెరిగితే అంత వర్క్ డన్ అనేది బ్యాటరీ చేయాల్సిందే. సో ఎక్కువ ఫ్యామిలీస్ అయితే ఎక్కువ వర్క్ చేయాలా, ఎక్కువ వర్క్ చేస్తే బ్యాటరీ తొందరగా డెడ్ అవుతుంది. ఎనీహౌ అది బతుకున్నంత వరకు ఒక ఫ్యామిలీని ఎంత పొటెన్షియల్ ఇవ్వాలో మిగతా ఫ్యామిలీకి కూడా అంతే పొటెన్షియల్ ఇవ్వాలి. సో ప్యారలల్ సర్క్యూట్ కనెక్షన్లో potential is same. When three capacitors are connected in parallel, their potentials are same. So each capacitors has a potential V. Okay. So for the C1, charge is Q1, potential V. For capacitor C2, charge is Q2, potential is V. For capacitor 3, capacitance is C3, charge is Q3 and potential is V. See here, at this the point, charge is divided. So Q is divided into Q1, Q2, Q3. So in parallel circuit, charge is divided into Q1, Q2, Q3. So charge is divided into Q1, Q2, Q3. So what is the formula actually? Q is equal to CV. See here, we take the first capacitor. So what are the terms here? C1 QV. So instead of Q, Q1, C is C1, potential is V. So Q1 is equal to C1V. So Q1 is equal to C1V. Similarly, Q2 is equal to C2V. Similarly, Q3 is equal to C3V. So taking V is common, then we get C1 plus C2 plus C3. Bring V toward this side, then we get Q by V is equal to C1 plus C2 plus C3. So what is the Q by V? That is C, equivalent. That is equal to C1 plus C2 plus C3. So this is the formula when three capacitors are connected in parallel. Then we get C equivalent is equal to C1 plus C2 plus C3. How do you write the answer for this question? First, C1, C2, C3, three capacitors are connected parallel. Let charge Q1, Q2, Q3, let Q1, Q2, Q3 are three charges are stored in C1, C2, C3 respectively. Let V the potential across C1, C2, C3 respectively. See here, we have Q is equal to Q1 plus Q2 plus Q3. You know Q1 is equal to C1V, C2V, C3V. So V is the common. So that is C1 plus C2 plus C3. Bring V towards this side. Then we get Q by V is equal to C1 plus C2 plus C3. So what is the Q by V? C equivalent. That is equal to C1 plus C2 plus C3. So this is the answer. See here, this is the answer. Okay, don't confuse with the other question. So what is the other question? Derive. Okay, derive the expression for the capacitance of the parallel plate capacitor. So this is the other question. So mostly students confused these two questions. Observe these two different questions and write the correct answer for each question.